Hi everyone. Today we are going to talk about the 3D printing technology will radically change the way in which space exploration missions are carried out. Medicine to manufacturing, the way in which scientific experiments are carried out in space, among other very important uses for the technology development. The topic of this video is experimental investigation of mechanical torsional characteristics of bolts constructed by 3D light printing. In the next few minutes, we are going to explain the experiment and the reason why this is necessary.
3D manufacturing today represents great advance in technology, and printing any mechanical parts is always a challenge. Now, stereolithographic is a type of technology to print 3D parts with high precision. The process works by solidifying liquid resin through a polymerization reaction. 3D printing based on digital light processing is a well-recognized area with a great technical and commercial potential. In addition, additive manufacturing is still underutilized as an industrial process, but it's growing rapidly with the development of innovative techniques and materials for some application. Thus, an important topic to address is bolt manufacturing. Bolts made of polymers are fasteners to lightweight mechanical systems where high corrosion resistance is required. In the realization of this bolt printing process, three different resins are used to print specimens, bolts, and nuts, with the technologies explained about using different printing parameters such as orientation and layer thickness to determine the characterization of the materials, mechanical properties, dimensional tolerance after printing, and subsequent curing, applying the corresponding standards and tests required for each case study. The specimens were manufactured by stereolithography, which is a laser technology that uses a liquid resin sensitive to ultraviolet light. Two resins 3D printers, the four lamps and the Anycubic printer were used for this purpose. An important part of the experimental analysis of any type of mechanical test is to know the characteristic of the material to be used, for which the characterization of the resin is very important. For this experiment, as mentioned, three types of resins were used, which are gray and clear resins from four lamps and high street resin.
Hello, I am going to present the results of our experiment. Observing in detail the O-interval graph shown in figure 7, it could be affirmed that the values of torque at back catch of the element by torsion present a statistical difference of the means for each type of resin with which the bolt was printed. The analysis of variance present in the table 5 corroborates the previous statement since the p-value is practically null. Bolts printed white formats clear resin demonstrate significantly higher torsional breakage resistance over bolts manufactured with other resin type. This is unstable, as the clear resin behind transparency allow for a greater depth of cure, cause more top layers to be overcured at each UV light projection interval, thus giving the material greater darkness. During the experiment, the bolts that were printed using FDM technology with PLA material suffered a collapse of the thread instant at breaking completely. If this happened in all test cases, the shape and where the pins were working also indicates the tip of hardness achieved in the resin at its solidity during printing as shown in the figure. Thank you.